Hi guys and gals, this is your chemistry review for your quiz on Friday, August 24th, just like I'm in the classroom. Couple of quick announcements. Make sure that you preview this video tonight, this afternoon at some point, at least once, because I will only give you 20 minutes in class to look at it, and you don't want to be pressured for time. Announcement 2, please bring your headphones to class tomorrow to make sure that you don't disturb your classmates. So let's go. All right, first topic, uncertainty and measurement. Remember, this is worksheet 2, and this is also under announcements. You can look at this website for uncertainty and measurement. So you have a blue measurement scale in centimeters, and you have a white metric scale. The blue measurement scale is obviously more precise with the little tick marks. And remember, you could only estimate one number. Whatever place that is, 10th place, 100th place, etc., you can only estimate one number. Don't forget your units. The blue scale says clearly it is centimeters. So whatever your value is, you need to have centimeters after it. Metric scale is kind of hard. Doesn't really tell you what it is. So units would be an acceptable answer. Go ahead and stop the recording, and I'll meet you on the next page. So for your blue scale, a measurement between 1.85 and 1.87 centimeters should be relatively accurate. On the white scale, however, you're only able to estimate to the 10th place, so 1.8 is probably one of the best guesstimates you're going to be able to make. If you have any questions, don't forget to look at worksheet 2. All right, moving on. Uncertainty and measurement. Remember, you have to get eye level with any kind of cylinder burette so that you can understand what's going on. You take the measurement from the bottom of the meniscus. Just like here, you would take the measurement from the bottom of the meniscus. And then you're to determine your answer in milliliters. So I want you to go ahead and stop the recording, figure out what your measurement is, and check to see if you're right. I'll see you on the next slide. So the volume reading was determined to be 34.60 milliliters. So again, we're looking at eye level, 34.1, 2, 3, 4, 5. The bottom of the meniscus lines up right at 6.0. So 34.60 is your guesstimation for your eye level. You will have a burette bonus question on your quiz. Make sure that you look at it. I will have it up at the front just like I did in class. And it'll be food coloring, so you'll be able to see it for your bonus question. So make sure you look at that. All right, density. So density, as we're talking about, is the amount of stuff, meaning your mass, per the space provided, meaning your volume. Okay, so density, as we learned in your lab today, is mass per volume or mass divided by volume. In this picture, you guys can see that I have a cylinder of each kind. Okay, assume that they are the same size. That looks like the aluminum one's a little bit bigger. But you want to know what's going on if you increase something or decrease something. So if I increase my density, then what's going to happen to my volume? So you guys need to practice. I went ahead and weighed your aluminum and copper cylinder. And your aluminum cylinder was 24.3 grams, and your copper cylinder is 61.7 grams. I provided the density for you, so all you have to do now is figure out what happens to volume. You're going to have to rearrange that formula. Stop the recording, and I'll see you on the next slide. Wow, so what we found out that with aluminum's density, we have 9 centimeters cubed, and with copper's density, we had 6.9 centimeters cubed. So in this case, when I increase my density, my volume decreases. That is called an inverse relationship, which I'll go over for you in just a bit. So if I increase my density, my volume decreases. But I don't want to just look at density because you have mass in this equation. So let's figure out what happens here. Okay, so if I increase my density, what happens to my mass? So let's look at this. I have 9.9 9 centimeters cubed for my volume, and a 2.7 grams per cubic centimeter for my density for aluminum. And then I have the values listed below for copper. So let's see what happens when I rearrange my formula to find mass. See you on the next slide. All right, so I'm taking my mass. I found out that it was 24.3 grams, so my electronic scale works. We're good to go for aluminum, and 61.8 grams for copper. So as my density increased, and here's how you're looking at this, the 2.70 grams of aluminum versus the 8.96. That 8.96 is a larger number, so my density is increased and my mass is increased. So they have what's called a direct relationship. See you on the next slide. All right, don't panic at your graphs. I'm just trying to get you to understand what's going on here. So my density versus mass, you can see it's a direct relationship, which is what we call linear. Okay, so the higher up it goes, the longer the straight line is, to infinity and beyond. Okay, and the other graph I think is pressure versus volume, but you get the general idea. It's an inverse relationship. It's this kind of curved graph. Okay, so I want you to understand the difference. So directly proportional to mass, inversely proportional to volume. Okay, I wanted to make sure you guys understood what was going on with the density and the volume, because I think it was harder to see in the classroom. I was able to do a photo snapshot, and you can see that the cold water is the one that is on, it's with the food dye that's blue, and it's just kind of chilling. It's just kind of hanging out. You know, it'll get to the bottom when it feels like it. It's on beach time or 5 o'clock time, whatever you want to call it, margarita time, etc. And the one with the orange food coloring, it hit the bottom. It's ready to roll. Okay? So I'm racing to the bottom, tag, you're it. Okay? Let's think about this though. Our volume is dependent on temperature. And what that means is it has a direct relationship with temperature. So if I increase my temperature, then my volume should increase. Okay? However, my mass remains the same. So the density, when my mass remains the same and I increase my temperature as well as my volume, then my density is going to fall or decrease. So I want to make sure that makes sense to you guys. So let's look at this next slide. Again, volume and temperature are dependent on each other. Here's an example on the little graph. Okay, so it's a linear relationship. Higher my volume, higher my temperature is going to go. So your hot particles, remember, hot particles are going to be moving a lot faster, bouncing into each other, hitting each other, okay? So they're going to reach the bottom faster. The cold particles are just the chilling. They're hanging out and, you know, they'll find their way down, wind in. They're taking a leisurely Sunday drive, etc. Okay? So hopefully that helps you understand how density and temperature are related. I thought this was funny, so I wanted to make sure you understood mass, volume, and density. And whoever came up with the tennis ball chair is my hero, because I want one of those. Seems pretty cool. Again, so a relationship for all of these. Mass, amount of stuff in an object. The amount of stuff that's in your tennis ball. Volume, the space the stuff is in. Okay, so this case, it's your little container. Sometimes it has labels on it with the different manufacturers. And density is the amount of mass, the amount of stuff per space that stuff is in. Okay? Make sure you understand all three of those. They will be on your quiz tomorrow. And weight. Weight, there's a couple different things we can talk about. Weight of a human body. I ate too much and I have to get on a scale. Or the dreaded driver's license information you have to put there. By the way, I Googled a driver's license, and there's a funny one of Obama, although inappropriate, so I couldn't put it on here, so you might want to check that one out. Or we're talking about the weight of an object due to the force of gravity. Okay, that is the weight that you'll be using in chemistry and physics. So think about that. Due to the force of gravity, it's the reason why we don't walk on Earth where we levitate. Well, some people try to attempt that, but anyway. Okay, it's the reason we don't float in the air, okay, because of the force pulling on us from gravity. And I believe that is all, folks. Yes. So make sure you study worksheet number 2. Again, go under announcements. Make sure you understand the uncertainty of measurements with link and volume. Make sure you have looked at that Eureka video with volume and mass and density. All of that is under announcements. And if you can look at all this and understand everything that's going on here and understand what we did in the lab, you're ready to rock it. See you Monday. Have a great day. Good luck. May the force be with you.